Hi, and welcome. This is Matt, and today's challenge problem will look at deriving the angle sum formula for cosine. Now, when you use your phone, it uses something known as dual tone multi-frequency, or touch tone dialing. So back in the 1960s, Bell Lab tried to develop an alternative to the rotary dial phone. And what it did is it laid out a standard matrix layout for our phones that we see today in our cell phones and iPhones. And it laid out this 4x3 matrix where 1 is in the upper left-hand corner, and we have all the way into 0, pound, and star in the bottom row. And each row represents a low frequency, and each column represents a high frequency. So, for instance, when I dial the number 8, my phone sends an 852 hertz frequency and 133.6 hertz frequency, and those two touch tone dialing, those dual tone dialing, that's how it determines that I've actually hit the keypad of 8. Now, how does it actually determine based on these two frequencies which keypad it is, that it's 8? Well, it uses something as the sum to product trigonometric identities. So we have sinusoidal waves, it's the tone, and we're actually going to be deriving these formulas together today, or at least attempting to. So we want to use information about the unit circle, the measure of angles, and the distance formula to derive an equation for the cosine of the sum of two angles. And one of the hints that we'll start with is to start with the difference of two angles first. So if I visualize this in the unit circle, well, here we have the unit circle, and I have an angle A here, I have an angle B going here, and then A minus B is the green one shown. And what I could conceive of doing now is, well, taking this triangle and shifting it along the unit circle such that B is at the point 1, 0. So now I could have the same triangle, my same angle A minus B, but I've just relocated the points. And so now, using the distance formula, well, these two lengths are equal. They're the same triangle, so those two chord lengths are going to be equal. And so what I could think about doing is, well, I could take distance formulas and set them equal to one another for those two yellow distances of my chords. So let's go ahead and do that. So here I have the two distance formulas together. So you'll see here that this distance formula is the distance between the point 1, 0 and cosine of A comma sine of A minus B. So it's this circle here. And the other one is looking at the distance between the point cosine B sine B and cosine A sine B, those 2 points there. And so now I have a formula relating cosine of A minus B and cosine of A and cosine of B. And what I'll try to do now is to simplify this formula and to solve for one of these values. So if I do that, well, I take away, I square both sides, I get the following. And now I can expand out these squares. So if I expand out the squares, I'm left with the following equation, which is fairly complicated. But what I can notice is that once I expand it out, I move around some of the terms, is I'm left with values that are equal to 1. So here you'll see cosine squared A minus B plus sine squared of A minus B. Well, that's the same as 1. And on the right-hand side of my equal sign, I have cosine squared B plus sine squared B. So that value is 1. And this value is 1, and this value is 1. So those can all be converted into 1s. Now if I combine all my terms together, I have 2 minus 2 times cosine of A minus B equals 2 minus 2 cosine A cosine B minus 2 sine A sine B. And so since I have a 2 on each side of the equation, so here I have 2 and here I have 2, I'll just subtract those and get rid of them. Then I'm going to divide each of these by -2, and now I have a formula for cosine of A minus B. So I'm almost there. I have a formula that relates cosine of A minus B in terms of cosine and sine of A or B. So I've now proven the difference formula, but I wanted the sum formula. So we're almost there. So now I need to find the cosine of A plus B. Well, I could think about using information from my unit circle. So if I have cosine of A minus B as my starting point, I could think of taking cosine of A minus a negative B. So what that means is I have this angle here where B, I could think of the angle here being negative B. So I plug those informations in and I try to use information about my unit circle and the quadrants to simplify this expression. So on the left-hand side, cosine of A minus a negative B, well, that's just cosine of A plus B. So I've simplified that expression out. And cosine of negative B is the same as cosine of B. Well, why is that? Well, because they're the x values. So the x values here are the same, whether it's B or negative B. But the y value, so sine of B, is going to be opposite. So now I'm left with an equation for my formula, cosine of A plus B equals cosine A times cosine B minus sine A sine B. Phew! So I feel like I've derived an equation for the sum of my cosine of A plus B. So I can go back to Bell Labs and I can give them this formula so I can figure out what keypad I actually dialed on my phone. Well, let's use this information to interpret a diagram. So if I have the formula for cosine of A plus B, a lot of mathematicians will present this following diagram, where here we have A and B as alpha and beta. And this visual diagram is supposed to show the formula that we've derived. So let's try to interpret this diagram for why this shows the cosine of sum of A plus B. So here we have B. Oops. So here we have B. Here we have A plus B. So we were doing, looks like we were doing this value here, A minus B, and then that shifted value. And they have the products. I'm not sure how this diagram shows the angle sum. I know that I have cosine A, cosine B is down here in purple, and sine A, sine B, this is in blue. So that minus that is, I guess, would be this length. How's that cosine A plus B? I'm not quite sure. Do you have any concepts for how this diagram could be used to show cosine of A plus B? I'll have to think about it. Some other things we might consider: would our formula be valid for all angles? Well, I use distance formulas, so in theory this should work for all angles. What if the angles were the same measure? So if A was equal to A, and then I think I'd get the cosine of 2A. So I could have the double angle formula. And how would I derive formulas for sine and tangent? Can you think of ways that we could create sine and tangent? So what's the sine of A plus B? I don't know. That is puzzling. Well, thank you to all of our sponsors for helping create these wonderful videos.